So we're going to be talking about graph databases and Neo4j. So this is me. I'm on the developer relations team at Neo. Feel free to email me or reach out on Twitter. I'd be happy to chat with any of you. Here's our agenda for today. First, we're going to cover what is a graph database. We'll look at some use cases, why we would use graphs in a graph database. Then we'll look at some Neo4j specific product features, including our data model, the Cypher query language. We'll look at some performance and scalability features that make Neo4j very attractive for the enterprise market. We'll have a short demo, and we'll look at some resources to get started with Neo4j. And finally, we'll be sure to leave plenty of time for any questions you might have. So we're going to be talking about graphs and graph databases a lot. So before we get started, I just want to make sure we're all on the same page here. These are charts, and this is a graph. So when we're talking about graphs, we're talking about a data structure with nodes and relationships that connect those nodes. We're not talking about charts. So to put things in context here, we know that data is increasing in volume. There are new digital processes, online transactions, social networks, devices are generating data now. So we have this huge new volume of data, and data is becoming more and more connected. So customers, products, these devices, they're all interacting, and in the real world, they relate to each other. The problem is that the tools we've traditionally used to handle relationships and data actually don't work that well with handling relationships. With relational databases, despite their name, there's actually really no model or store data to handle relationships without adding complexity. So we can write joins to handle relationships in a relational data model, but this adds complexity, and we really see performance degrade significantly when we start to do multiple joins. Writing the queries becomes very complex. And when it comes time to add new types of data or new relationships, we then have to redesign our schema, taking a lot of time. So for these reasons, traditional relational databases are really inappropriate for handling data relationships. On the other hand, we have a whole category of NoSQL databases, such as document databases, key value stores, but we have similar problems there too. We don't have data structures that really model or store relationships. Most of these databases don't really have a good query construct to query relationships. Often we end up writing join logic at the application layer, and we don't have support for ACID transactions, many of these. So for these reasons, many NoSQL databases are inappropriate with handling data relationships in real time as well. So that brings us to Neo4j. Neo4j is an enterprise-grade graph database that allows us to natively model and store our data as a graph. We can query relationships in our data in real time, and this has some significant benefits for application development that we'll see. So what are the business benefits of using a graph database? Well, we know that using the right tool for the job can have significant impacts for our business. Our customers have told us that using Neo4j has allowed them to develop new functionality, gain new insights from their data, write better software that's less complex, more performant, better user experience, and bring their products to market much faster, which ultimately results in lower costs. So let's take a step back and examine some specific use cases where it makes sense to use a graph database. So the first thing that often comes to mind when you're thinking about graphs and graph databases are social networks, things like Twitter and Facebook, where we're dealing with relationships with our friends, people that we know, people that we follow, things like that. And sure, that's a good application for graphs and graph databases, but there's really so much more beyond that. The first case I want to talk about is fraud detection. Many of our customers have found that by modeling financial transactions, credit applications as a graph, they're able to very quickly and easily discover fraud rings and fraudulent transactions. Another great use case is IT network analysis. So consider the data center, all of the machinery and devices that exist in the data center, your applications that are running on application servers, database servers, how all of these devices interact, and being able to model that as a graph and query the status of those devices in your applications in real time is really a significant benefit for monitoring your IT network. Another great use case, recommendations. So consider product recommendations or content recommendations or even social recommendations. These all have to do with relationships in the data. There are really two categories of recommendations that take advantage of these relationships. With content-based recommendations, we're dealing with how users have interacted with items in our network. With collaborative filtering, we're looking at calculating similarities between users in the network and making recommendations based on that. But both of these approaches are based on relationships in our data. Great, so let's look at some Neo4j product features. These are sort of the key highlights of Neo4j. We have our native graph store, which allows us to query the graph very, very efficiently with native graph processing. The data model, we like to say, is whiteboard friendly. We'll see an example of this, how the graph data model is actually very intuitive. Neo4j has full ACID support for transactions. We'll take a look in a minute here at Cypher, which is our powerful and expressive query language. That's often much more simple to write than SQL. Neo4j Enterprise has some scalability and high availability features, such as server clustering, that we'll take a look at as well. Neo4j has built-in ETL tools for loading your data initially and importing from other databases. We also have lots of integrations with drivers, popular languages, and frameworks. So let's dive into a few of these key features. The first one we're going to look at is what we call the property graph model. So oftentimes, when you're first starting to tackle a problem, you'll go to a whiteboard in a meeting room and start drawing out the entities you're dealing with, how these entities relate to each other, and you end up drawing a graph because this is very intuitive. This is how we think about problems. What's amazing about Neo4j and graph databases is then that when we go to actually implement our application, the whiteboard model that we drew to intuitively think about this is the same physical model that we're using in our database. So this is what we mean when we say that the data model is whiteboard ready. Think about how we would have to model that in a relational database. So on the right here we have a simple graph model for a social network where we have Andreas and his friends, and he has this nose relationship directly to his friends. That's very simple to model in a graph model. However, to do this in the relational model, we need to have some sort of join table to do a lookup there so that we can actually look up the friends of Andreas. This at one hop is manageable, but imagine that now we have other relationships that we need to manage as well. This quickly becomes very complex. Let's look at the components of the property graph model. So we talked about nodes and relationships earlier. Nodes are the entities or the objects in our graph. Nodes can have key value properties. So here we have two person nodes, one with the name of Dan and one with the name of Anne. We know these are person nodes because these have labels on them. That makes this really the labeled property graph is another way to think of it. Our relationships are connecting nodes, and they can also have a type and key value properties. So here we have a person driving a car, person owning the car, where the brand is Volvo. So this is really our property graph model. So we talked about the data model. How do we actually write queries to insert data and query our graph? Well, we do that with Cypher, which is the Neo4j query language for graphs. Here's an example at the bottom here. Cypher is really all about pattern matching. So here we're defining labels for our nodes, key value properties, name Dan, name Ann, and we've defined some relationship that's connecting these two nodes. And this is a create statement. So if we executed this, this would insert two nodes into our graph with the loves relationship, noting that Dan loves Ann. Let's take a real-world Cypher example. This came from one of our customers. So imagine an organizational hierarchy, and we want to find for a specific employee all of their direct reports, how many people they manage, count those, and then traverse that up to 3 levels deep in the organization. So this is the SQL query that the customer was using to do this. This is very complex. Imagine being the developer having to maintain this. When they implemented that in Neo4j, the same Cypher query was used to solve this problem. So you can see here we're just using simple pattern matching to find our reports and count those. So much more expressive and very easy to express complex queries. One project that we're really excited about is OpenCypher. OpenCypher is an open source project that will make the Cypher query language available for other vendors on other graph projects. We hope that Cypher can really become the SQL for graphs. Okay, so often the first step in a Neo4j application is getting data into Neo4j. We have a couple of different ways to do that. One is the Cypher-based load CSV. We'll see an example of this in a minute. This is good for loading data up to about 10 million nodes and relationships. If we have data that is significantly larger than that, we have a command line tool for bulk loading data. This is very performant. Testing this locally, we can import all of dbpedia, which is about 4.5 million nodes and their relationships, and we can do that in about 100 seconds. So very, very, very performant. So let's dive in and look at some other performance and scalability features that Neo4j offers. We hear again and again from our customers that Neo4j is enabling new use cases and actually making existing applications much, much faster. Neo4j Enterprise offers a master-slave replication model so that you can run multiple instances of Neo4j side by side. Each instance can maintain its own cache of the graph for increased performance. We call this cache sharding. So this clustering model really enables high availability with fast real-time operations. Great, so let's break into a demo of the Neo4j browser and look at some real-world data. The data we're going to look at is a graph of US Congress. So this data comes from GovTrack, which maintains data about US Congress, so legislators, the bills they work with, the committees they serve on. And we imported this data using load CSV Cypher. So here's a little snippet of that from CSV files from GovTrack. So you can see how we use that ETL tool. So this is the data model that we're dealing with. We have legislators, the bills they voted on, sponsored, the committees they serve on, the states they represent. We have topics of the bills. Those are the main entities we're going to be dealing with. So let's hop out of here and jump into Neo4j browser. So this is the Neo4j browser. This can run in your web browser and connects to instances of Neo4j. In this case, I'm running it locally. We can see here the nodes that we have in our data. So I've already loaded the Legis graph, data about US Congress. We can see the relationship types that we have. We can write some queries directly into the browser. So here we're just looking for 10 legislators, returning that at random here. We can interact with our data here. We can look at the properties that we have. So this is a great workbench for writing queries and interacting with our data. Let's look at a couple of interesting queries here. So when I first moved to California, I didn't really know anything about politics in California, so this was a great way for me to explore the representatives of California and some of the legislators here. So this Cypher statement is going to match on this pattern here. So we're going to look for legislators that represent a state, or that state is California, and then we're going to return the state and those legislators. So when we run that, we see here's state California. Here are all of our legislators that have this relationship to California. So these are the legislators that represent California. Let's jump out of here. Let's look at another query. So this one's somewhat similar. We're going to look at legislators that represent California, but now we're also going to match on the party that they're a member of and the body of Congress that they were elected to, and then return all of that data. And so here we have that. So now we can see our House Democrats, our House Republicans, and our two senators over here. So the Neo4j browser is a great way to visualize your data as a graph and interact with that, writing queries, do that in real time. I just want to look at one last query here that'll show another feature of Cypher. So this query I really like. It shows the power of graphs and graph traversal. So we're going to start out, again, looking at our California legislators. But now we're going to look at the committees those legislators serve on, what bills were referred to those committees, and then for those bills, what are the subjects of those bills? So what topics are they dealing with? We're then going to aggregate on that subject and count the number of paths that we've found for those subjects. So this query should return us, in order, the most often topics dealt with by California legislators in the committees that they serve on. And we switch to the row view here. So now we can see these are the topics that our California legislators are most dealing with in U.S. Congress: congressional oversight, health, armed forces, and things like that. Okay, so that was just a quick demo using some real-world data of the Neo4j browser, just to give you an idea of what that looks like. I've left the queries that we ran in the slide deck here, so you can check that out later. So finally, I want to talk about some resources that we have for getting started with Neo4j. By far the best resource that we have is the Neo4j community. We run meetups worldwide as part of our community. We have over 100 technology and service partners, our great enterprise customers, lots of downloads. There are lots of ways that our community interacts and lots of ways to get started with Neo4j. If it's answering questions on Stack Overflow, meetups. We recently launched a public Slack channel so that the community can keep in touch with other Neo4j users around the world. That's a great way to share what you're working on and get feedback. There's also an O'Reilly book on graph databases. This is available for anyone at graphdatabases.com. There's some great content here talking about why you would use a graph database, really diving into some specific use cases, and a great way to learn Cypher and how to use Neo4j. Another project I want to mention is our GraphGist portal. So a GraphGist is a document that anyone can write that embeds Cypher queries and graph visualizations that come from Neo4j. So this is a great way for the community to share use cases that they're interested in and put those out there. And we call this the GraphGist. We're currently running what we're calling the GraphGist Challenge through the end of the month. We're asking community members to write up a GraphGist and submit that to our GraphGist Challenge that will feature your submissions. And we're really hoping to uncover some interesting use cases and interesting data here. As an incentive, we're offering some great rewards for this challenge, so be sure to check that out if you're interested. That's running through the end of the month. So finally, I just want to leave you on a few points of what makes Neo4j and graph databases sort of the defining characteristics. That's our property graph data model. Nodes and relationships are the entities in that data model. Remember that we have native graph processing with Neo4j using the Cypher query language to efficiently query your graph. So be sure to go to neo4j.com to download Neo4j and get started.